When you look at nature, you see patterns everywhere. A snowflake that repeats its arms, a seashell that spirals smoothly, a galaxy that curls like a whirlpool. Even your own body is nearly mirrored left to right. These patterns are not accidents. They come from one of the deepest principles in the universe: symmetry. But here is the twist. If the universe only had symmetry, everything would look the same. Nothing would stand out. Nothing would grow. Nothing would have identity. The universe needs symmetry, but it also needs something else: broken symmetry. Together, symmetry and broken symmetry create the shapes, structures, and directions that give the universe its character. Today we explore how this works and why it is one of the hidden engines behind all complexity. Part 1. What symmetry really means. Most people think symmetry means being perfectly balanced or mirrored. But in science, symmetry means something deeper. A system is symmetric if nothing changes. When you move it, rotate it, flip it, or shift it. A perfect circle is symmetric because it looks the same from every angle. A calm, still pond is symmetric because every point is the same as every other. An empty universe would be symmetric because everything would be identical everywhere. Symmetry is simplicity. Symmetry is uniformity. Symmetry is the absence of differences. But here's the problem. If everything is symmetric, nothing interesting can happen. The universe needed something more. Part 2. What broken symmetry means. Broken symmetry is exactly what it sounds like. The moment a perfect pattern becomes imperfect. This imperfection creates uniqueness. It creates direction. It creates structure. Imagine a pencil balanced on its tip. That is perfect symmetry. But the slightest nudge will make it fall in a specific direction. That direction is broken symmetry. Snowflakes break symmetry when tiny vibrations make one branch grow faster. Galaxies break symmetry when gravity pulls slightly unevenly. Life breaks symmetry when a cell chooses front and back, top and bottom, left and right. Broken symmetry is the spark that turns sameness into shape. Part 3. The universe begins with a symmetry break. Right after the Big Bang, the universe was nearly perfectly symmetric. No shapes, no differences, no structure. But then, something remarkable happened. Tiny fluctuations broke the symmetry. Some regions became slightly denser, some slightly hotter, some slightly more energetic. These small differences grew over time. Galaxies, planets, and eventually life. If the early universe had stayed perfectly symmetric, it would be empty and featureless today. Broken symmetry created everything you see. Part 4. Symmetry creates rules. Broken symmetry creates reality. Symmetry gives the universe its fundamental rules. The laws of physics are the same everywhere because the universe has symmetry in space. Energy is always conserved because physics has symmetry in time. Electric charge works consistently because the laws have internal symmetries. Symmetry gives order. Broken symmetry gives form. You need both to have a universe filled with structure that still obeys stable laws. Part 5. Examples everywhere in nature. Symmetry and broken symmetry show up at every scale. In atoms, electrons have symmetric clouds until energy breaks the symmetry and creates chemical bonds. In molecules, spirals form when symmetry breaks in a specific direction. In cells, left and right sides begin symmetric until development breaks it and creates organs in fixed positions. In ecosystems, species spread symmetrically at first until food, climate, and behavior create new patterns. Galaxies, matter spreads evenly until gravity breaks symmetry and spirals appear. Symmetry is the starting point. Broken symmetry is the creative moment. Part 6. Why symmetry breaking creates identity. Imagine if every snowflake were identical, or every human face or every thought in your mind, identity would vanish. Broken symmetry creates differences. Differences create meaning. Meaning creates complexity. Two identical cells become different only when symmetry breaks. Two identical stars become unique when they form in slightly different environments. Two identical ideas become distinct when your brain processes them differently. Identity requires difference, and difference requires broken symmetry. Part 7. The universe's most important symmetry breaks. Some symmetry breaks are so important that they shape the universe itself. One is the breaking of the unified forces. In the early universe, all forces were one. Then symmetry broke and split into gravity, electromagnetism, and the nuclear forces. Another is matter beating antimatter by a tiny margin. A single broken symmetry is why anything exists at all. Another is the Higgs field, choosing a direction in its energy landscape. This break gives particles mass and allows atoms to form. The universe is a history of symmetry breaking at exactly the right moments. Connecting this to PIWCWG. Now let's link this. PIW is the persistence information weave. It says patterns survive by weaving information forward in time. CWG is the Carroll-Wells gradient. It describes how persistence moves upward through layers of complexity. So how do symmetry and broken symmetry fit? Symmetry provides stable rules that let information persist. Broken symmetry introduces differences that let new patterns emerge. Together they form a perfect pair. Without symmetry, patterns would fall apart. Without broken symmetry, patterns would never change or grow. PIW describes how patterns persist. CWG describes how patterns expand. Symmetry and broken symmetry describe how patterns are born. Part 9. Why the universe needs an imperfect balance. The universe could not work if it were perfectly symmetric. It also could not work if symmetry were completely gone. It needs a delicate balance of order and imbalance, stability and creativity, rule and surprise. Symmetry keeps the rules steady. Broken symmetry lets the universe evolve. This balance is what turns simple beginnings into complex endings. Closing. So the next time you see a snowflake, or a spiral galaxy, or even your own reflection, remember this. The universe did not build these shapes by staying perfect. It built them by allowing small imperfections to grow into beauty. Symmetry gives the universe its laws. Broken symmetry gives the universe its forms. Together they create everything you see. Join us next time for episode 25, where we explore how small causes can create huge effects over time, and why the universe is full of amplifiers, feedback loops, and unexpected transformations.